A local model can get smarter without getting bigger, but the cost often turns up in speed or memory. This test puts that trade-off under a microscope with two IQ4NL versions of the same 9 billion parameter Qwen 3.5 model running multi-token prediction on one consumer GPU. DavidAU's Defiant Fable, Heretic Neo, is a heavily fine-tuned build with a modified quantization file, while Unsloth supplies a straight quantization of the base model. They share the same architecture, so this is a useful choice between lean throughput and a fine-tune built for stronger capability. Both ran on the same Ryzen 7 and RTX 4070 Ti Super through llama.cpp, with multi-token prediction enabled and all 34 layers on the GPU. The setup used a 98,304 token context window, flash attention, and 11 fixed prompts from short chat inputs to more than 77,000 tokens. Each run generated 256 completion tokens. The intelligence comparison needs a clear caveat. These scores are self-reported on DavidAU's model card and use comparable 8-bit rows, not the 4-bit files from the local speed test. They are indicative rather than independently verified, but DavidAU leads the base 9 billion model on 6 of 7 benchmarks, with its biggest reported gains on ARC reasoning and open book questions. The larger reference models add context, but they were not part of this local benchmark. DavidAU ties Qwen 3.6 27 billion on ARC challenge and beats it on ARC Easy plus OpenBookQA, while the larger model leads on Boolean questions and several common sense tasks. DavidAU also wins 5 of 7 reported tests against Qwen 3.6 35 billion A3B, and wins 6 with 1 tie against Qwen 3.5 27 billion. That does not make the 9 billion model universally better, but it is unusually strong reported reasoning performance for its size. Generation speed flips the result completely. Unsloth wins every one of the 11 prompts, averaging 153.36 tokens per second, against DavidAU's 108.08. The straight quant is 41.9% faster on average, which matters for batch workloads, concurrent users, and anyone who wants the shortest possible responses. That lead persists at every prompt length. On short prompts, Unsloth leads by 39.7%. At medium lengths, it averages 169.84 tokens per second, against DavidAU's 125.89. On prompts above 5,000 tokens, its advantage expands to 55.3%, averaging 126.17 tokens per second, while DavidAU averages 81.24. The longest test makes the long context difference especially clear. With more than 77,000 input tokens, Unsloth still reaches 105.43 tokens per second, and DavidAU reaches 69.01, a 52.8% advantage. The measurements show the gap widening at long context, but they do not establish a single confirmed cause. That matters for document questions, retrieval pipelines, and codebase analysis more than for short chat. Prompt processing is essentially a draw. DavidAU processes prompts at 2,834.48 tokens per second, while Unsloth reaches 2,842.54, a difference of only 0.3%. Time to first token is effectively the same here, so the practical split happens during generation. Both models fit all 34 layers on the GPU, but DavidAU measures 9,854 megabytes of video memory, while Unsloth uses 8,806. Unsloth leaves 1,048 megabytes more headroom for a larger batch or concurrent requests, although both fit this test configuration. The choice is clean. Pick Unsloth for maximum throughput, stronger long context responsiveness, and a leaner memory footprint. Pick DavidAU when its reported reasoning uplift is worth slower generation and more memory, because 108 tokens per second is still fast for interactive chat. These models share an architecture and a quantization label, yet the benchmark shows how much the final file can change the balance between speed, memory, and capability.